responsible for these Starburst Foundation brochures that you may have seen wandering around here, and that's one of his current projects. He's apparently a man of many projects. He received his Bachelor's of Arts degree in physics from the Johns Hopkins University in 1969. He has a Master's in Business Administration as well, and a PhD in Systems Science. He has done quite a bit of research in respiratory protection. He invented a miniaturized pulsation dampener for air sampling pumps. He's got some patents on rebreather apparatus equipment. He also founded in the mid-70s a group called Solar Aquatics, a solar energy research firm. As a matter of fact, I'd heard of that while I was in the solar business at that time, and it did some very significant work. He's also worked as a project consultant on solar energy for the Club of Rome. He's lectured extensively in the United States and in Europe. In addition to his work in microphysics and astronomy, he's also investigated the application of general theory of open systems to the fields of stock market theory, psychology, prebiotic evolution, and ancient mythology. So, without further ado, here's Dr. LaViolette.
I'm going to talk about a new physics theory called subquantum kinetics, which I got the first time I got the idea was in 1973, and I developed it over the years and was published in 1995 in this journal. There's a sequence of 3 papers in here. Basically, what it does is it replaces quantum mechanics and a lot of other theories in physics with a more unified approach. One of the problems in physics that I see is its fragmented nature. The tendency has been to operate from observations, and you construct theories. You know, it's sort of like the blind men and the elephant. You know, they go up and they say, here's what I say. They focus on a particular area and they devise a theory, and then another area and devise a theory. And then later on, some guy comes with needle and thread and tries to sew them together into sort of a patchwork quilt. Just to give you an example of the inconsistency that this can reach, there's what's called the cosmological constant conundrum, which was discussed in Scientific American a year ago, which shows that quantum mechanics, the quantum electrodynamics theory and general relativity are mutually contradictory. These are the 2 foundations on which physics is formed. The idea being that with quantum electrodynamics there would be so much mass in every millimeter of space that the gravitational redshift would be such that we couldn't be having this conversation because I would be in the radio region of the spectrum. In other words, the light, by the time it got to you, would be in radio wave region. So this is a major problem in physics, and it hasn't been resolved. What it would be good, if you can, to wipe the slate clean of all the theories you've been taught, and just to hold on to the observations to see this new approach. It's sort of like taking a journey to another area. And what I'd like to do is show you the door, how to get there. I've been there for many years, and I can understand how it might be difficult to grasp some of this new perspective, because it is basically a totally new way to view physical reality. And when you've gotten there slowly, bit by bit, it's much easier than all at once. But basically, let me begin with this. This is an example of the Zhabotinsky reaction. This is a chemical reaction that produces what are called chemical waves. This is what's called an open system. To relate this to, before I get into this a little more, I'd like to say that what this physics theory relates to in the Tesla area is that it predicts waves, electromagnetic, or I shouldn't say electromagnetic waves, I should say radiation waves, light waves, radio waves, which are very similar to what Tesla was talking about. He used the image of waves being like sound waves, rather than like what Maxwell was saying, where the waves are conducted through transverse motion. Okay, so The reason why subquantum kinetics makes different predictions than the Maxwellian theory is basically the model it uses for wave motion and for particles, subatomic particles, for example. Current physics has used what's called the mechanical model. In other words, it goes back to the time of Huygens looking at the ripples going across the Dutch Canal, and that became the model for light. Okay, that's the mechanical wave motion model. It was postulated there was a mechanical ether. The ether was something that was just a substrate, and waves were imposed on it. And as a result, you got all of physics. The formative years of physics were based on this model. Faraday, all these big names, they were working with a mechanical ether. The field concept developed in the mechanical ether. Maxwell's equations. Then the ether was abandoned with the turn of the century. It wasn't disproven, it was abandoned with going to special relativity. And still the equations were retained, which means the ether, mechanical ether, was there, sort of like the grin on the Cheshire cat, still hanging in space. The thing is that around 20, 30 years ago, we suddenly discovered that there was another type of wave motion. These are called chemical waves. The principles are totally different. But looking at it from a historical perspective, this only happened at this point in history, at a time when physics was completely developed. Now, subquantum kinetics takes for the first time a chemical approach to physics. Not just chemical, but organic. In other words, the basics of this theory are essentially the same as what the principles as govern what happens in your own body. It's in effect an incursion of biology, or I should say more generally, systems theory into physics. When I first got this idea, I was very heavily involved in general system theory. I don't know how many people have heard of it. Anybody heard of general system theory? Okay. It's basically viewing that the sciences have divided up nature artificially. And there's really only one science, that things happen a certain way and you can form general principles about it. Of course, you have modifications in different areas. But you can find in things called systems, like we are a system, our organism, a cell is a system, this chemical reaction is a system, society, subatomic particle, that there are certain properties which they have in common. And general system theorists are sort of like the honeybees of the sciences. They bring ideas from one field into the other. They cross-fertilize the disciplines. Avoids reinventing the wheel. So what I've done is take principles that were already developed in chemical kinetics and systems theory. I've drawn from people like von Bertalanffy, Ludwig von Bertalanffy and his theory of open systems. Ilya Prigogine, Nobel Prize winner, his work in nonlinear dynamics, and I've applied them here in physics. I postulate an ether, instead of a mechanical ether, a reaction diffusion ether. And just as an example, I always get tangled in cords. Okay. This shows some of the differences comparing mechanical waves to reaction diffusion waves. The mechanical waves, the carrier is inert, whereas in the reaction diffusion system, the carrier is interactive. It's metabolizing. It's an open system. When I say open system, I mean that it's in a state of flux. An example here, a very nice example, because it's actually a transmuting system, is a candle. Now, presently it's an equilibrium system, but if we light it, it becomes an open system. In other words, the wax feeds the flame, and as a result of the transmutation, of the combustion, we have the flame produced. The structure of the flame depends critically on the process continuing. Therefore, structure is dependent on process, which is not true in the closed system models. Your body is an open system. If you were to stop eating, you'd find out very quickly. Society, the example of the energy crisis of '73 when they cut off the oil supply, so what major impact it had. I'm suggesting also oh, yeah, a little dimmer. The universe also, I'm suggesting, is an open system, that there's a flux passing through the entire universe, through this room, maintaining everything in the room. So this ether is in a state of reaction, whereas the mechanical ether of the 19th century was, in effect, at thermodynamic equilibrium. Its entropy remained constant. Entropy is always increasing in the reaction to fusion ether. When I say reaction to fusion, I mean that the molecules, or whatever it's consisting of, the etherons, are both reacting with each other and they're diffusing through space. You see what I mean in a moment about reacting. In the mechanical version, the carrier plays passive role, whereas in this case of the reaction to fusion ether, it's actually sustaining the wave. Excuse me just a moment. Okay. The waves are produced deterministically in mechanical case. Here they can rise spontaneously. Here, mechanical case, waves require external stimulus. Here, they arise out of the order in the reaction system itself. Think of it this way. Imagine a medium with waves. The medium itself has a structure to it in the sense of the way it's reacting with itself. And by postulating the mode of reaction, you can get different kinds of behavior at the physical level. See, you go to with this physics, you start at the subquantum level, and you make postulates about the way the ether is reacting. And there's an infinite number of models you can propose at that level. And you model the models to see what they predict in terms of what kind of waves emerge, and you look to see if it's realistic. Is it something that behaves according to what we see as physical reality? It's a total different approach to physics. It's a modeling approach rather than an observational approach. Every time you talk about ether, it's good to mention the Silvertooth experiment was recently done, and it's shown that for the first time it's shown that we are moving with respect to an absolute reference frame. He took two laser beams and aimed them at each other, produced an interference pattern, standing wave pattern, and measured the distance between the nodes. And he found that the nodal separation was a function of the direction it was aimed. And from this, he was able to calculate the speed of the Earth relative to the absolute ether frame, came up with a figure of 378 kilometers per second towards the Leo Aquarius axis, a line in that direction. And this checks perfectly with what they found by studying the anisotropy of the 3 degree Kelvin microwave background radiation. They come up with 377 kilometers per second towards the constellation of Leo. In my written work, I've mentioned Marinov. Marinov did some experiments on trying to measure the speed of light, one-way speed of light. But I don't cite his work anymore. There's some doubt has been cast on his work, so I'd rather cite Silvertooth's. Okay, here's a picture of the reactions that are going on. I'm postulating, imagine we have several different kinds of etherons, and they're reacting according to this set of reactions. In other words, we have inputs A and B and output Z and omega. That's what makes this an open system. You have input and output. X, Y, and G are variables. They're allowed to vary, whereas these we hold constant. I'm suggesting that the physical world is made out of variations, waves of these three. And here's an example of what this might look like if you were to make a hydrodynamic example. You're starting here with A. That's etheron concentration. The concentration is represented by the height of the water level. And the flow out of this into G, the transmutation from A to G, it's sort of like a chemical reaction going on, is proportional both to the concentration, in other words, the head of water, and the size of this orifice, which is determined by the kinetic constant, K. And so on down the line. And you also have reverse reactions going on with reverse constants. And these are for all of these. I just haven't drawn them in. This is what it looks like if you do it formally. This is a chemical kinetic approach. Actually, I've taken a model already developed by Prigogine and his group called the brusellator, and I've modified it. To get the brusellator, you just take these two equations and you substitute A goes to X. Okay. But you need to put in the G to make it physically realistic. I won't go into that. Here are the equations you write that represent G, X, and Y as variables. And if you model these on a computer, theoretically you could produce subatomic particles that would attract each other, just like according to the laws of electrostatics and gravitation. Here's what it looks like if you string these out according to the level of reactivity. In other words, you put the A and B higher, because it's sort of like the input levels, and the Z and omega lower, and there's also other states upstream and downstream. And here is the physical universe. So we define in effect what we call a transmutation dimension. This whole thing, all of these etherons transmuting, constitute together an ether, the transmuting ether. It's collective ether. Okay. Individually, if we represent the individual etherons by these letters, we find that they would react similar in this fashion. These are just two of the equations I showed previously, just schematically represented. In this physics, you get into the idea of critical thresholds. Wave behavior doesn't emerge initially. It's if the reaction system is what we call subcritical. Think of a nuclear reactor. I don't want to start off the alarm. Like in a nuclear reactor, it's subcritical. You remain with the uniform distribution of the ether in a subcritical state. However, if a certain part, imagine a certain part of this ether becomes supercritical, then fluctuations in the ether can become amplified and turn into particles. And this is what we call a bifurcation diagram. In that as you increase the criticality of the system, of the ether, you come to a point where suddenly the uniform steady state is unstable and you have two possibilities now. This is where wave patterns emerge spontaneously now from the ether. And the two solutions represent a positive and negative particle, sort of like matter and antimatter. So that falls out of this naturally. This shows the sequence that goes on. Initially, this is the vacuum state, the beginning of creation before the emergence of matter and energy. By the way, you don't need a Big Bang theory in this cosmology. So imagine that the G and Y, we're not plotting X here just for simplicity. Imagine these ethers are uniformly distributed initially, and the space is initially subcritical. Then imagine that at a certain point you get a gravity fluctuation. The G represents gravity, and X and Y are representing the electrostatic field. Now these are potentials. In this physics, etheron concentration is identified with energy potential. So G would be equivalent to gravity potential and X and Y electric potential. The reason you need both X and Y for electric potential has to do with the polarity it's the nature of the system. You need the two X and Y. They behave to each other like yin and yang. In one polarity, X is high, Y is low, and the other, Y is high, X is low. And this is the way, without that, you couldn't get particles. And it's just a natural thing of the system. And this is not an ad hoc thing. This is pretty much very general. This is in a lot of fields. You know. Imagine now that you have gravity fluctuation. Now, in this theory, what regulates the criticality of the ether is gravity. Okay? Now, what you in fact do is produce a supercritical region, and if by chance an electric potential fluctuation, in other words fluctuation, let's say in Y, happens to arise at the same moment within the supercritical well, then you get amplification. Eventually it grows into a particle. But of course the particle has, in this case, let's say it's a proton, generates a gravity field. So it self-stabilizes itself. Sort of a bootstrapping. Now, here we get into the idea of zero-point energy. In physics, they talk about quantum vacuum fluctuations. Those are different from what I'm proposing here. In the quantum fluctuations, you have to have a whole quantum emerge at a time. I'm talking about sub-quantum fluctuations that might be a millionth of that. And they don't get to a quantum level to be able to nucleate a particle until they grow, and that only happens under supercritical conditions. The advantage of this is it's a lot more probability to have a very tiny fluctuation than it is to have a huge fluctuation. You know, maybe you do get quantum fluctuations, it allows it in this physics, but they are just extremely rare. You know. So this makes the creation of the universe extremely probable. Okay. If you were to look at what this particle would look like when it emerged, this is in 3 dimensions. If you were to do a computer simulation of it, it would look like this, sort of like concentric spheres. We're doing a cross-section of it. In this case, a core that's high in Y and low in X, and then a shell high in X, low in Y, and it alternates like that, goes out. Now this has a certain specific wavelength. This is not ad hoc again. This drops out of the equations. If you were modeling on a computer, this is what you see. This is what you identify with the Compton wavelength. And here you have a very nice resolution of the wave-particle dualism. Okay? Because you have both a wave aspect and it's a particle. As you go towards the center, the field gets stronger. In fact, I show that if you scatter this from a diffraction gradient, it behaves just like what de Broglie found. This should have showed this earlier. This just shows a relation between concentration, ether-ion concentration, and energy potential. Here, this is equivalent to a vacuum, but as soon as you get a gradient in the potential, you have a possibility for force. So force emerges as a gradient of the energy potential, which is like it is in physics. The steeper the gradient, the greater the force. In subquantum kinetics, force is created by the potential stressing the subatomic particles structure. Okay, remember the subatomic particle is also a wave pattern in the ether, and when it's exposed to a gradient, it's in effect getting its patterns being stressed. And like in Le Chatelier's principle, a body will respond to relieve the stress. So its motion is in effect a action to adjust to that stress. And that's how you get motion and force. This is a little more detailed view of the particle. It shows that this is a positive charge, positive mass particle. Here's negative charge, negative mass. In the one case, the Y potential is positive, in another case, negative. And the gravity here goes down in the positive particle. That's a little, turns it around. You think positive, it should go up. But in this case, because gravity, the idea of gravitational attraction, we're talking about negative gravity potential. Whereas in the antiparticle, it would be greater. Now, one thing it indicates here is that there's a correlation between gravity and electrostatics, which fits with the Biefeld-Brown effect. Have people heard of this? Okay. So this is one beauty of this physics, is it naturally predicts the anti-gravity effect, and presently there's work has been done on this. Brown in 1958 got a saucer to levitate itself, and I know through contacts that there are black research programs in the U.S. Developing this. They have developed manned craft and have flown them. Okay, so we're not talking about theory. This is something that has happened. And people are scratching their heads because it doesn't fit in with Einstein's theory of relativity. By the way, Silvertooth's experiment throws out the door not only special relativity, because if you have an absolute frame, you can't have special relativity. It also throws out the window general relativity. General relativity needs relative frames. So the beauty of this physics is it offers an alternative gravity theory to replace general relativity. And it's one that's consistent with the Biefeld-Brown effect. Not only do you have these potential differences, okay, this again is not postulated. This comes out of the equations that you get particles that naturally charge themselves, plus and minus. In addition, you have fluxes, ether fluxes. Like, in effect, the ether will be flowing into this well from the environment in the positive particle. And in the case of the Y etherons, they'll be flowing outward. And the reason for this is that gravity, the graviton, or the geons I call them, are being consumed in this region faster than they are in the environment. And that just happens to be the way the equations are, that when it bifurcates, that's what happens. Whereas the Y-ons are produced in greater abundance here. And it's this property that produces the field. It's very interesting because here we have a model where the field and particle are one. They're continuous. So we have avoided the wave-particle dualism, which has plagued classical physics. Okay? The other thing is it avoids the infinite energy absurdity, which has plagued even modern physics. In that modern physics, the energy potential goes to infinity as you approach the center of the particle. As you see here, it goes to a finite value. Okay. If you were to visualize the particles, the fluxes, this shows what the fluxes would look like in the two charged particles. You could think of these like countries importing and exporting products. Imagine a country that's importing wheat and exporting computer chips, whereas the other country, the anti-country, is importing computer chips, exporting wheat, or whatever, the opposite. So basically, it brings also economics into physics. The future physicists may be accountants, who knows. Getting back to gravity, I just want to show you what the Biefeld-Brown effect looks like. You charge upper surface of the saucer positive charge, lower surface negative charge. Subquantum kinetics is suggesting that the positive charges are consuming G and the negative charges are producing G. So you get a net G flux going this way, and of course it goes around. And therefore you get a gradient from minus to plus, which is opposing the Earth's gradient. That's a very simple one. The other thing, Brown found that if you make the negative plate smaller, you get more lift. And the reason for that may be what's happening is there's more of a radial flow of the etherons. So when you get a flow radially, you get the opportunity for a spiral. And very possibly this etheron flux may be spiraling, and they found that this has an effect of improving lift. Just want to show you the equations briefly. In subquantum kinetics, these are the equations that you can derive for for electrostatic potential. We'll talk just about electrostatic potential, forget gravity for the moment. And here is the classical electrostatics. See how similar they are? The difference is in classical electrostatics, they don't define what Q is. They just say it's charged. It's just something that they put in to represent that. Whereas here, we've defined it out of the basic equations. We defined it because that X is being consumed and Y produced in a certain region. This is a diffusion coefficient in subquantum kinetics, and that would be equivalent to permittivity. The minus and plus are for the two polarity particles that are possible. And always the y is the mirror of x in terms of this is minus, this is plus. And from this you get fluxes, and these are the equations for the fluxes that we showed before. And this is what relates the flux to the potential. And this is standard in chemical kinetics. So all I'm doing is taking equations already been developed in chemical kinetics, applying them here. And here's the equation for electrostatic force field intensity from subquantum kinetics, and here's the standard one in electrostatics, and see again the great similarity. Eta is equal to 1 in this case, which is just a proportionality constant. Then from these you can derive these, which are the divergence and the curl, which are two equations of Maxwell's for electrostatics. And again, they're identical essentially to what is agreed. So I'm just showing you this to show you that it produces fields that are realistic, physically realistic. They're 1 over r potential fields, and the force fields are 1 over r squared. I don't really have time, unfortunately, to go into Panos Pappas' work, but just to mention briefly that Maxwell's laws have a flaw in that in his model he assumed that open circuits and closed circuits were behaving similarly. Just show a diagram. In other words, that these two circuits are identical, that physically closed circuit behaves identical to an open circuit where you have a capacitor here. Maxwell was assuming you had a displacement current flowing here. And Pappas' work has shown that there is no force that would be predicted. If there was a displacement current, there should have been a force, and his experiments didn't observe it. And it turns out that Maxwell based his electrodynamics on the Lorentz force formula, which this part is based on the Biot-Savart law, which predicts only transverse forces, magnetic forces, only transverse, not longitudinal. Pappas has found that the Ampere force law proposed by Ampere actually not only is it compatible with all the experiments that Maxwell's theory is compatible with, but also accounts for all the phenomena that Maxwell's equations don't. So this is the correct formula. And one thing that's different about it is it predicts not only transverse forces but longitudinal. For example, if you have a dipole antenna, you're going to have not only the transverse forces that Maxwell talked about, but also longitudinal forces of those waves. Here, good place to mention that. So here's the Maxwellian wave. In subquantum kinetics, here's what you have. Can you see that? High x, low y, and right next to it, high y, low x. That's all it is. And it moves forward. And this is a scalar wave. This is potential, energy potential, whereas here you're dealing with force vectors, okay? And this is very much like Tesla's concept, because Tesla was talking about the sound wave model, where you have compression and rarefaction of gas molecules in his gaseous ether. Here we have instead high concentration and low concentration of etherons. In other words, we have a chemical kinetic model. And chemical concentration is very similar to gas, except here you're dealing with ions in a solution, the density of ions, rather than concentration of gas molecules. So I think he would be very happy with us if he were here today. In fact, if he knew about chemical waves, he would have probably tried to work his theories into that model. This just shows one other experiment that Panos has done, the pi frame experiment. And with Maxwell's laws, you'd expect there was a force being applied here that was causing this pi frame to move forward when you put a current through it. There was another name for this, produced earlier.
Ampere bridge.
The Ampere bridge. Panos is designed a little differently, so it has more degrees of freedom. And when he rotates the current so it comes in from an angle from down, the bridge, instead of moving this way like Maxwell's equations would predict, moves upwards. And so these experiments, oh, and here's one other. This is the stigma antenna. He puts microwave radiation, and if Maxwell's equations were correct, there should have been forces here causing this to turn, and no forces were observed. And these two experiments not only disprove Maxwell's theory as a general theory, but also disprove special relativity, because the Lorentz force formula is a relativistic law, and these observations directly contradict special relativity. Here is the creation scenario for the universe. You have a particle by chance nucleating at a place where you have a sufficient supercritical region, and this supercritical region doesn't necessarily have to be the size of the particle. It can be a couple light years in diameter even. So proton comes into being. In the vicinity of the particle, another particle comes into being, because the nature of this is that the particle produces a supercritical well and increases now the probability of further nucleations taking place. So the next particle that emerges is very likely to be in the vicinity of the previous particle. So it's sort of like a biological reproduction that goes on. And so you get mother and daughter atoms being produced. Eventually you get a whole primordial gas cloud. And this can take trillions of years. Okay, you're dealing with an evolution that's far longer in time. The thing is, you think, well, geez, the Earth is only 4.5 billion years old, and shouldn't most of the matter be relatively young? Well, that's the thing. This is an exponential process, so most of the matter is relatively young. But out of that, you'd find a certain percentage that was quite old. As the gas cloud is produced, it eventually condenses into a primordial brown dwarf, which grows into a star, ignites, then the mother star produces a daughter planet because of its stellar wind. The planet grows into a star itself, and this process goes on until you develop a whole star cluster, and that turns into a dwarf elliptical galaxy of billions of stars. Then eventually the core, the mother star at the core, grows to such an extent, it becomes so energetic that it begins the explosion activity. These are what are called galactic core explosions. And as a result, the explosive force blows gas and dust out, which circles along a plane and forms the spiral arms of the galaxy. And eventually, every now and then, if the explosion is very great, it will blow out a small cluster of stars, which will become a new galaxy, sort of like a spore forming a new galaxy. Now, this is not new. These ideas have been proposed, that the galaxies can form this way. ARP is one person that suggested this, and Ambertsumian, even before him. Okay. Now another aspect, this gets us into free energy, because if we're talking about spontaneous matter creation in space, obviously this is an example of free energy creation. But we also have not only matter creation, but energy creation. In regions where the gravity around, like let's say galaxies, where gravity is negative, you get supercritical regions, and in between the galaxies you get subcritical regions. Therefore, photons would tend to gradually, their energy dampen in the subcritical regions and gradually increase in supercritical. Now, this is nice because there's a model called the tired light model. For example, the whole idea of the expanding universe was based on the idea that they found that galaxy spectra were redshifted, meaning they saw the light was redder. The frequency was shifted from what they expected, and so the only solution they had was that it was because the galaxy was moving away. It turns out actually that one other guy had proposed a model about 8 years before the expanding universe model took root, a guy named Nernst, back in 1922 or so, that the ether was absorbing energy from the light. and that's why it redshifted. So actually, and this became later known as the tired light model. So actually, the tired light model should be given precedence over the expanding universe model. But this is not mentioned by the cosmologists. The nice thing about subquantum kinetics is it predicts this in a natural way. This is not something as an ad hoc postulate. It's something that emerges naturally from the equations. In fact, this was a test I carried out. I developed subquantum kinetics. I knew nothing about astronomy. This prediction came. I said, well, this is true. Maybe the redshift, could be due to this. And so I worked out the equation, and there's a certain exponential relation you'd expect that as you go out in space, the longer you go out, further you go out, the more redshifting you get. And that's an exponential form. And so I plotted it against the data, and sure enough, it actually fit better than the expanding universe model. And this shows on the Hubble diagram test, galaxy redshift against distance. Here's the data, here's the tired light model, here's the expanding universe model. But not just on one test. This was the case on 4 different cosmology tests with 4 different data sets. And this was published in the Astrophysical Journal in 1986. And since that time, no one has refuted the results. So as far as I know, the expanding universe idea should be dead. Here's tired light. We're comparing the angular separation between galaxies in a cluster as a distance measurement, and here their redshift of a cluster. Tired light model, and here expanding universe model, you see it's too far up at the high redshift end. We were hoping to get some data with the Hubble telescope, but they couldn't, as you hear, focus the mirror properly, so we have to wait another 3 years. Here's another test. This is the galaxy number count test to count the number of galaxies you see in a certain region versus their magnitude, which gives you a distance measurement. And here's tired light model closer to the data points as compared with expanding universe model. Then even looking at radio galaxies and looking at their radio emission, here's the data, this hatched region. Here's the tired light model. Here's the expanding universe model. Okay, so the universe, according to subquantum kinetics, is static. It's not expanding. Therefore, you don't need a Big Bang. Small is beautiful. And another prediction is in the supercritical regions, you'll get this energy amplification taking place. Therefore, you would expect that, okay, it turns out that the amount you propose is so small you can't measure it in the laboratory. In fact, to explain all the energy that the sun is radiating, all you need in terms of the amount, you think of it as money in the bank that's collecting interest, okay? The amount of the sun's heat reservoir would be like the capital, and the amplification on each photon, each dollar in bank, would be like the interest. And the amplification rate is so small, it would be 100 million times smaller than what you can measure in the laboratory with the best instruments. So the only place that this could become apparent is at astrophysical levels. So that's why I say this aspect of subquantum kinetics is tested in the cosmological arena. One suggestion then is that maybe a part of the sun's energy is due to what I call genic energy. This is the name I've come up with. I call it genic, meaning spontaneously generated. And again, it's a form of free energy. It's different from the zero-point concept. But again, it's a form of free energy. So what I did, I found that you can plot the mass against the luminosity of the star. This is a standard diagram in astronomy. It's called the mass luminosity diagram. And they find that stars go according to what's called a mass luminosity relation. As they go up in mass, their luminosity follows a line. And this is the line that you predict by subquantum kinetics. Now there's a certain amount of error in that. This is the average of the line, but it's interesting that the average fits very, very nicely. The other thing, I've drawn this so that it actually matches the trend. But the actual average comes out to within a few percent of this. If you extend this downward and you plot also the heavy planets, notice they found that the heavy planets have internal heat sources. In other words, they radiate more energy than they receive from the sun. And actually, this occurred to me, well, if this is true in stars, then it means that we should find something in planets. I did some research. Sure enough, Jupiter they had found this was in the early days, back in 1978 when they were just finding this. Sure enough, I was thrilled to find that Jupiter had a heat source, and later they found Saturn and so on. And as you see, they also line up. Then if you extend this up to the Sun, you find the Sun is on a different trend line. Actually, the trend line takes an upward bend to a steeper slope. Instead of being a 2.75 power slope, it's a 4.0 slope. And that happens right about 45% of the Sun's mass that you get the steeper slope. This is called the upper main sequence, where the Sun is. And this is the lower main sequence, where these called red dwarfs are. Well, when you project this line up, it predicts about 2/3 of the Sun's energy, which is very interesting because they can only account for 1/3 of the Sun's energy in terms of the solar neutrino experiments. So this resolves what's long-standing called the mystery of the missing solar neutrinos. Now, there's also what's called the luminosity function. This is where you plot the number of stars in a certain luminosity category versus their luminosity, and you get this distribution. And as you see from this, most of the stars are in this lower main sequence, which I'm suggesting is totally run by genic energy. By the way, this reminds me, in that diagram, the fact that the planets and lower main sequence stars lie on the same relation is a very serious thing for fusion energy. Why, if it's not due to but just chance, it means that whatever's happening in the planets is also happening in the stars. So that rules out nuclear, because we know nuclear can't be fired up in Jupiter. It's just temperature's too low. And we know that if it's just primordial heat, like they suggest for Jupiter and Saturn and so on, it can't be what's happening in the stars, because they would have fizzled out millions of years ago. So there's some sort of ongoing generation-free energy that's linking these two. Now, what I'm suggesting is that all of these stars are basically run by pure genic energy. And right here, where you get this bimodal, it's very interesting. Right here, where that relation takes a steeper slope, you get a new distribution coming. And I'm suggesting this is where fusion energy kicks in. So these stars have a mixture of fusion and genic. And it's interesting that most of the stars are genic powered, 90%. Although these are the actually account for the lion's share of the light you see. Well, if we were to put, here's a listing of various kinds of energies. I'm suggesting genic energy is one of them. It's actually the most commonplace, natural type of free energy, and that's what runs the universe. So what we talk about subquantum fluctuations, which you meant here a lot, zero-point energy, could be considered another. And it's sort of related to this as far as the matter creation goes. Then there's an electromagnetic field extraction type of energy that a lot of times with these solid state transformers they claim are producing more energy than they use up. This could be due to the fact that we are moving relative to the ether frame at 378 kilometers per second. Now you see, in relativity theory, we're stationary, so there shouldn't be any energy possible to extract. But if we in our fields are moving relative to an absolute reference frame, then this implies a whole new restructuring, rethinking of field theory, and maybe what these machines are doing is extracting energy from our motion relative to the ether. And then there's also the possibility that if you can actually modify the gravity field, you can produce, instead of a see, the Earth has a diversion field, whereas if you could produce a curl field, one that folded back on itself, you could generate energy in unlimited amounts. In other words, if gravity always pulls in a circle, then all you have to do is put a pinwheel in the center, like a paddle wheel, and it spins infinitely. And actually, Brown did this experiment in 1958. He had to shut the power down because the wheel was ready to fly apart. So this is another source of energy. Well, we don't have time. I could go in and show you. I've got a list of 27 points where, on one hand, there's a problem in physics, and the right hand, how it's solved with subquantum kinetics. But I won't go into that. Any questions? Yeah.
Did Brown do those experiments in Paris? Was that his?
Yeah.
Okay.
Yeah.
You didn't say very much about magnetic.
Oh, I missed that. Okay. Magnetic fields. Okay.
Possibility of magnetic monopoles.
Okay. In subquantum kinetics, a moving electrostatic potential is what creates your magnetic field. There is no magnetic potential. This is one thing that's different from a lot of what you're hearing from other people. They're suggesting there's a magnetic potential. In subquantum kinetics, you don't have that. All I'm saying is that magnetic forces are due to an electrostatic potential moving relative to that charge. In other words, that when you have think of this like a water going down a well, you know, like the X being drawn in. If you move that, you not only do you create a longitudinal wave, but you have a transverse component to it. And if you study it, you have not only divergences, but curl products. And it's those curl products that create the magnetic force in that theory.
I'm wondering where you're denying the relativity theory.
Yes.
And relativity theory has had many successes, like even you adopted one on the redshift, and that's a really general relativity result.
No, that's Doppler. The standard view of the expanding universe version is that's a Doppler shift.
Well,
The tired light model has nothing to do with...
no, that's not true. Actually,
Wait a minute.
General theory says that when the potential is lower,
Yeah.
that there will be a blue shift.
Okay.
When the potential is higher, you'll have a redshift.
That's called the gravitational redshift.
What you had.
No, that's the gravitational redshift. I wasn't talking about that. That's the reason why certain white dwarfs have their lines redshifted.
Well, that's a minor.
That's a different thing, and subquantum kinetics predicts a gravitational redshift. Okay.
What I wanted to say is that relativity theory has had so many successes, and to just throw it out through the window like that in favor of something that you have based on speculations that somebody might think are not well founded, to me it looks like not a good deal, really.
If I was talking to a systems audience, they would understand everything I said. This is firmly grounded in systems theory. There's nothing speculative about it. Okay, this is chemical kinetics. Yeah, that's a whole field of science.
Well,
It's based on this.
The chemistry
And what you're contesting is not my theory, but the question of whether there is an ether. And I'm saying that Silvertooth's experiments have shown that there is an absolute reference frame, and that tosses special relativity out. Yeah.
I was wondering if Silvertooth's experiments have been repeated by others, or is he the only person who's detected?
Okay, so far they haven't. He used a very expensive photomultiplier tube where he took a TV tube and cut off the end so that the laser beam could actually pass through it and illuminate the photosensitive surface. And something like that, you're talking about investment of $50,000. He had some friends at GE that produced the tubes for him. So that's been an impediment for people to reproduce his experiments. So as far as I know, no one has reproduced the experiment and said it's wrong. Now, before this is true, before the scientific community is going to accept what he did, they're going to wait for other people to reproduce. Now, this is the case with all situations. Now, I've personally met Silvertooth. I've looked at, read his papers carefully, gone through the whole thing, and observed that his result checks with the anisotropy very closely, the dipole microwave, and suggest to you and letting you in on something before it hits the newspapers. The rest who want to be more skeptical, fine.
Could you give us the references where we can read about your...
Yeah, this is for sale for something like $17 in the bookstore.
What's the name of it?
It's the General Systems, the blue book, International Journal of General Systems, which notice it was published in a systems journal and not a physics journal.
Okay, you're forgiven.
There's also there's another paper, that the Astrophysical Journal paper on the cosmological redshift is also out there.
Does your theory explain the Einstein effects? For example, the orbit of Mercury precesses.
Yeah, that's a mass change effect in this physics. mass increases. If you have two stars and they get closer together, their mass actually increases. I don't want to take up any more time from Panos. I just wanted to mention, I just remembered, a critical thing I forgot to say was that I talked about dipole motion, but I didn't talk about if you have a monopole antenna, like that Tesla sphere you had, where you pulse the sphere, you're changing the charge sinusoidally, so you have no charge motion. In subquantum kinetics, you would get pure longitudinal waves radiated out. In other words, it'd be like rarefactions and compressions of the ether. And that would produce pure longitudinal motion, would be scalar wave, pure scalar wave.
Is there the formation of those wells that you described there? Is that an ongoing process that's happening right now?
Yeah, it's ongoing matter creation process. In fact, they found some fresh matter not too far from our galaxy that hasn't formed a galaxy yet. Yeah.
What kind of peer review has your theory undergone?
This was systems theory. Now, this was because before I submitted to General Systems, no one could understand my theory because they were trained in mechanics and not chemistry. This is the problem. When it was submitted to systems theorists, because they work with chemical kinetics very frequently, and Prigoghine's type of work, what I heard was both referees recommended publication. They had no criticism at all. And I have not heard any criticisms yet. You know.
And how long ago?
1985.
Have you tried to reinterpret the Michelson-Morley experiment?
Michelson-Morley experiment? Okay, Silvertooth's experiment's not in contradiction with that. Michelson-Morley measured the two-way velocity of light. And Silvertooth had gone through the mathematics on that, and he shows how everything is compatible. Yeah.
Now, in fact, the magnetic machine pulls energy out of the moving matrix, we're moving through it, or it's moving through us.
Yeah.
Pursuant to the principle that for every action there's an equal opposite reaction, and then we create a drag.
Well, maybe we could talk about that later. Yeah.
Which can be measured.
Yeah. Okay, then. No, that's it, I guess. Panos.